We shall continue with the discrete and continuous bivariate random variables. Question is, the joint probability mass function of a bivariate random variable x comma y is given by p of x comma y is x comma p of x, pxy of x comma y is equal to k into 2x plus y for x is equal to 1 comma 2, y equal to 1 comma 2, 0 otherwise. Find the value of k. Find the marginal probability mass function of x and y. Are x and y independent? So here x and y are clearly discrete random variables. Bivariate discrete random variables, so discrete values are 1 and 2. Y x values are, for x is equal to 1 comma 2, y value is 1 comma 2. The joint probability mass function pxy of x comma y is given as k into 2x plus y, and for all other x values, x and y values, pxy of x comma y is given as 0. What should be this k value? Now since pxy of x comma y is a joint probability mass function, its sum for all x and y values must be equal to 1. Since it is a bivariate random variable, its sum means sum over x and sum over y. So double summation pxy of xi comma yj must be equal to 1. Inner summation symbol we can take the sum over y, and outer summation symbol we can take the sum over x. Or I can write it as a double summation for x is equal to 1 to 2 and for y equal to 1 to 2. For these x and y values, the joint probability mass function pxy of xi comma yj or pxy of x comma y will be k into 2x plus y. So that sum must be equal to 1. Now expand this double summation, take x as 1, then take y as 1 and 2, get this sum. So for x is equal to 1, for y equal to 1 it is k into, since k is a constant, it is kept outside this bracket, then 2x plus y, put x as 1 and y as 1, 2 plus 1. Put x as that 1 and next y value 2, 2 plus 2. Then take x as a 2, y as 1 and 2. So for x2 and y1 it is 4 plus 1. Then for x is equal to 2 and y equal to 2 it is 4 plus 2. So that sum must be equal to 1, or that sum will be 18. So 18 into k, 18k is equal to 1, or k is 1 by 18. Then the second part, find the marginal probability mass function of x and y. Marginal probability mass function of x means px of x. Marginal probability mass function of y, py of y. So for marginal probability mass function of x, px of x, it is the sum of the joint probability mass function pxy of x comma y, where x is fixed same x value, then y varies, so summation over yj or j. So x is fixed whenever it is marginal probability mass function of x. For a discrete random variable x, it is summation first of all, and marginal probability mass function of x means x is fixed, y varies. For the fixed x value, you need to calculate the probability of that x value and the possible y values, sum of all that probability. So it is summation y equal to 1 to 2 pxy of x comma y. Pxy of x comma y means it is 1 by k into 2x plus y, where k is 1 by 18 for y equal to 1 to 2, keeping 1 by 18 outside the summation symbol. 1 by 18 into, it is 2x plus y, by putting y as 1 and 2, 2x plus 1, then plus 2x plus 2. So altogether it will be 1 by 18 into 4x plus 3. So the marginal probability mass function of x, px of x is 1 by 18 into 4x plus 3, where x is 1 and 2. In particular, by putting x as 1 and putting x as 2, you can calculate the probability mass function px of 1 and px of 2. Then marginal probability mass function of y, similarly py of y is equal to summation pxy of xi comma y, where now y is fixed, x varies. So summation pxy of x comma y, where x varies, for x is equal to 1 to 2, y fixed, and pxy for x is equal to 1 to 2, y equal to 1 to 2 is k into 2x plus y, where k is 1 by 18. So put in place of pxy of x comma y, 1 by 18 into 2x plus y, where x is from 1 to 2. Keeping 1 by 18 outside the sigma symbol, now 2x plus y, you take the sum of that by putting x as 1, x as 2. So 2 plus y, then 4 plus y. 1 by 18 into 6 plus 2y, where y varies from 1 to 2. The discrete values of y are y equal to 1 and y equal to 2. Then the third one, are x and y independent? For that you have to see the joint probability mass function pxy of x comma y, whether it is same as px of that x value into the marginal probability mass function py of that particular y value. Even if there is one such pair x comma y for which pxy of x comma y is not equal to px of x into py of y, then x and y are not independent. Here if you consider 1 comma 1, x is 1, y is 1, then pxy of x 1 comma 1 will be k into 2x plus y, where k is 1 by 18, and in place of x and y you have to put 1 and 1. 1 by 18 into 2 plus 1, 3 by 18 or 1 by 6. Now px of 1 means marginal probability mass function of x at x is equal to 1. Px of x is 1 by 18 into 4x plus 3. In that you put x as 1. 1 by 18 into 4 plus 3. 7 by 18. Similarly, marginal probability mass function py of 1. Look at that py of y, the marginal probability mass function of y, in that you put y as 1. 1 by 18 into 6 plus 2, 8 by 18. Multiply px of 1 into py of 1 means 7 by 18 into 8 by 18 or 56 by 324. And now you can see pxy of 1 comma 1, the value is 1 by 6, which is not equal to the value of px of 1 into py of 1, that is 56 by 324. Since their values are not equal, x and y are not independent. Probability that x is 1 and y is 1 is C. x0, y0, x0, y1. That means the sum of that probability will be nothing but px of 0. So this I can write it as same as px of 0, the marginal probability mass function of x for x is equal to 0, which is 0.5. If I take x as 1, then it is probability that x will be less than or equal to 1, means probability that x will be 0, probability that x is 1. Along with this x is equal to 0, you have to combine with that x value with possible y values. You have to combine this x value which is 1 with the possible y value. So here it comes 0, 0, 0, 1. Then here it will be 1, 0, 1, 1. Sum of the probability for x is equal to 0, y equal to 0, and x is equal to 0, y equal to 1 is nothing but f, the marginal probability mass function px of 0. Similarly, this will be marginal probability mass function px of 1, which will be 0.5 plus 0.5, which is 1. Now if we go for the marginal CD of fxy of x comma infinity, which is already calculated, that we can write it in terms of unit step function. For x is equal to 0, it is px of 0. Possible x values are 0 and 1. For x is equal to 0, consider the marginal probability mass function px of 0, which is 0.5. Combine it with the unit step function u of x minus 0, u of x plus. Next x value is 1. So take the marginal probability mass function px of 1, which is 0.5. Combine it with the unit step function u of x minus 1. Similarly, if we go for joint CD of fxy of infinity comma y, where y is 0 and y is 1. fxy of infinity comma y same as fy of 0 for y 0. Probability that y is less than or equal to 0. So this less than or equal to 0 means there are no values for y less than 0. So only possibility is equal to 0. With that y value that is 0, you have to combine it with all the possible x values. X values are 0 and 1. So x0, y0, x1, y0. So it is same as py of 0, sum of that probabilities, which is 0.5. When y is 1, fy of 1, probability that y is less than or equal to 1, possible y values are 0 and 1, so 1 included, so it will be p of y equal to 0 and p of y equal to 1. In this, the possible combinations are y0, x0, y0, x1, so 0, 0, 1, 0, which is same as py of 0. In this possible combination of x and y values are y is fixed, which is 1, x can be 0 and 1. So combination will be 0, 1, 1, 1. Means it is same as py of 1. 0.5 plus 0.5 is 1. And now you can represent this in terms of unit step function. fxy of infinity comma y will be equal to py of 0 is 0.5. 0.5 into del u of y minus 0. Py of 1 is a 0.5. So 0.5 into u of y minus 1. Last part, are x and y independent? Just like the previous one, take xy as 0, 0, then the corresponding joint probability pxy of 0, 0 is 0.2. Look at the table. Fx of px of 0, 0.5. Py of 0, 0.5. If you multiply px of marginal probability mass function px of 0 and py of 0, you get it as 0.25, which is not same as the joint probability of x and y at 0, 0, which is 0.2. They are not equal, therefore x and y are not independent. Next question, the joint PDF of x and, that is random variable x and y, is given as fxy of x comma y is c for all x values greater than 0 less than 3, y values greater than 0 less than 4 and 0 otherwise. Now looking at that x and y value, x varies in the open interval 0, 3, y varies in the open interval 0, 4. So both x and y are continuous random variable. So this will be bivariate continuous random variable. So this fxy of x comma y will be the joint PDF of bivariate continuous random variable. What is the value of a c? What are the PDF of x and y? Again, for the continuous random variable x, in this bivariate random variable, PDF of x means it is the marginal probability density function of x. Similarly, marginal probability density function of y, fx of x and fy of y. Then what is capital letter fxy of x comma y? That is joint CDF of x and y. when x is greater than 0 less than 3, y greater than 0 less than 4. The only difference between this and the previous question is here x and y are continuous random variable. In the previous question x and y were discrete random variables. What are fxy of x comma infinity, fxy of infinity comma y? Means marginal CDF. Are x and y independent? So again a question from the model question paper 2020. First, to find the value of a C, you are given the joint PDF means double for a single random variable, integral of that PDF from minus infinity to plus infinity must be 1. Since it is bivariate random variable, fxy of x comma y is the joint probability density function, means double integral of this from minus infinity to plus infinity must be equal to 1. But here x values are 0 to 3, y values are 0 to 4. Except for these x and y values, fxy for remaining x and y values are zeros. So in this integral you need to consider x from 0 to 3, y from 0 to 4. Inner integral can be with respect to x, outer integral with respect to y, or vice versa. Inner integral with respect to y and outer integral with respect to x. Here we have taken inner integral with respect to x, so x is from 0 to 3. Outer integral with respect to y, so y is from 0 to 4. Then this fxy of x comma y is c, which is straight away taken outside the integral sign. So c into integral 0 to 4, integral 0 to 3 dx dy is equal to 1. Integral dx means x, differentiate 3 and 0, which will be 3 minus 0 or 3. So 3 kept outside the integral sign, 3c. Into integral 0 to 4 dy equal to 1. C 3c into integral dy is y, differentiate 4 and 0, which is 4 minus 0 or 4. 3c into 4 is 12, so 12c is 1. C is 1 by 12. What are the PDF of x and y? Means the marginal probability density function of x, denoted as fx of x, which is equal to integral from minus infinity to plus infinity. The joint probability density function fxy of x comma y. Now marginal PDF of x means integration is with respect to y. Marginal PDF of y means integration is with respect to x. So here integration with respect to y. So y value varies from 0 to 4. For remaining y values, this integrand will be 0. So consider the integral only from 0 to 4. So that integrand fxy of x comma y is c. C kept outside the integral sign, which is 1 by 12. Integral 0 to 4 dy means y, differentiate 4 and 0. 4 minus 0 is 4. So this integral will be 4. 1 by 12 into 4, or it is 1 by 3. And x varies from 0 to 3. For all x values from 0 to 3, the marginal probability density function fx of x is 1 by 3. Marginal probability density function of y means fy of y. Now integral from minus infinity to plus infinity, joint probability density function, marginal probability density function of y, so integration with respect to x. And x varies from 0 to 3, so integral will be 0 to 3. fxy of x comma y is c, which is 1 by 12, kept outside the integral sign. Integral dx means x, differentiate the upper and lower limit. 3 minus 0 is 3. So 1 by 12 into 3, or 1 by 4. Fy of y is 1 by 4 for y values between 0 to 4. Then the joint CDF, fxy of x comma y. Formula is actually integral from minus infinity to x, integral from minus infinity to this particular y value. In case of continuous bivariate random variable, for a joint CDF, this is the formula. Look at what are this x and y value. That x and y values are taken as the upper limit in this double integral. But x value varies from 0 to 3, no negative values for x. So in this outer integral you have to start from 0, lower limit 0, 0 to x. Similarly, y value varies from 0 to 4, no negative value comes in this interval. So y for inner integral it is 0 to y. Then you can take this integrand fxy of x comma y as a c. For all other x and y values, this integrand will be 0. So need not consider that other values. C can be kept outside the integral sign. Inner integral 0 to y dy means y, difference at y and 0, y minus 0 or y. So 1 by 12 into integral 0 to x, this is y dx, y kept outside the integral sign, y by 12. Integral dx is x, difference at x and 0 means x minus 0 is x, y by 12 into x or xy by 12, where x varies from 0 to 3, y varies from 0 to 4. Similarly, fxy of x comma infinity, marginal CDF of x. So in the previous formula, in case of continuous bivariate random variable, this is the formula for joint CDF. Now y is infinity, so you can put upper limit y as infinity. Y varies to infinity, from minus infinity to plus infinity. Now since x varies from 0 to 3, no negative values comes in this. So in the outer integral you start from 0. Ignore others, 0 to x. Y varies from 0 to 4. So in the inner integral you take integral from 0 to 4. Ignore other values. So that fxy of x comma y can be replaced by c dy dx. C kept outside the integral sign. Integral dy is y. Difference at 4 and 0 means 4 minus 0 or 4. So it becomes c is 1 by 12 into 4. 4 by 12 into integral 0 to x dx. 4 by 12, 1 by 3, integral 0 to x dx means it is x, difference at x and 0 or x minus 0, which is x. So it will be x by 3 for x greater than 0 less than 3. Similarly, fxy of infinity comma y. Now put x as infinity, minus infinity to infinity, inner integral minus infinity to y fxy of x comma y dy dx. Since x and y varies from 0 to 3 and 0 to 4 respectively, ignore negative value which comes in this integral. So in both integral, lower limit will be 0. 0 to 3 x1, x value. 0 to y, where this y will be from 0 to 4. C is a constant kept outside the integral sign. Integral dy is y, difference at y and 0 means y minus 0 is y. So it will be c is 1 by 12 and this inner integral is y, so y by 12. Outer integral 0 to 3 dx, or it is x, difference at 3 and 0 means 3 minus 0 or 3, y by 12 into 3, 3y by 12, y by 4. So this fxy of infinity comma y is y by 4. For y value no x comes in this. So for y values between 0 and 4. Last part, are x and y independent? Look at that fx of x, marginal probability density function of x calculated in the second part, fy of y. If we multiply, then for x greater than 0 less than 3 and y greater than 0 less than 4, it will be 1 by 12. Same as c. So this will be equal to c for these x and y values, 0 elsewhere, which is same as fxy of x comma y given in the question. So fxy of x comma y is same as fx of x into fy of y. So condition satisfied, therefore x and y are independent. We'll continue more questions in the next.